gonna use an impact, but it's okay because I got that trigger control.
This video is brought to you by Sporlan, quality, integrity, and tradition.
This is the restaurant where I had a restricted expansion valve, and we ended up having to change the dryer too. Actually, we had a restricted dryer and the expansion valve was gummed up. Customer called and said the kitchen's still hot. So I came here and the kitchen's 75 degrees. The AC is working. It's kicking butt. But as they were saying like, oh man, it's still not working. And so I'm driving back out here and I'm thinking, okay, the compressor failed or whatever. No, everything's running. I haven't put gauges on anything, but it's not restricted. Suction lines are cold. Vital signs seem fine, and it's nice and cool in the kitchen. But in talking to the customer, they said, yeah, and the dining room's hot. And I said, wait, dining room's something totally different. This is the kitchen. So they said, yeah, the dining room's hot too. And it's like, okay. Well, as I was walking up on the roof, I noticed that this is their dining AC right here. And I noticed that the main breaker downstairs is tripped for this AC. So we need to open this guy up, power it down up here, and reset it and figure out why the main breaker would have tripped downstairs. Now, why they're complaining about the kitchen AC, I don't know. I'll look and see. So what I did was I powered down at the disconnect switch right there, and then we're gonna go downstairs, reset the breaker, and then come up here and test everything. Come over here. RTU2 is tripped. It's in the mid position, so turn it on, it doesn't do anything. Off, then on. Don't see any issues there. We're gonna check voltage. We're gonna do visuals before we turn everything on. Ohm everything out to ground. Nothing's jumping out at me. Electrically, we look okay. Don't see any major shorts that I know of at the moment. It's pretty big if it tripped the main breaker and didn't blow like a fuse or something, so. All right. The power's off to the unit. Belt's snug. No funky noises. Don't see any burnt anything. Wires. Nothing scary. See how the filters are. Filters look relatively clean. These are from the filter changer. Don't see any issues there. Huh. Okay. I tested 3-phase at the disconnect switch. It was correct. 208 3-phase. So we're gonna go over here, grab our meter, and start checking at these compressors. This is an 18-ton, so we got 4 compressors in it. We're gonna tone everything out, make sure we don't have any direct shorts. I'll show you what I find. So I've tested every compressor to ground. I get nothing. I've tested the resistance across the pins on each compressor, and they're all fine. I get no direct shorts to ground on any of the load sides of the contactors. I also don't get any direct shorts to ground on the line side of the incoming power. I pulled the wires off of these capacitors and tested the capacitors while they were sitting here, and I do have some capacitors that are bad. 3 of them are actually measuring really low. I'll show you right now. 10 microfarad capacitor. The first one's measuring 10.21. Let's jump on to the next ones. So on these capacitors, it's let's see, plus or minus 6% on this one. So it's running 10.21. We're allowed to run 10.6, so that one's good. This one's plus or minus 10%, and it's running 7.5, so that one's low for sure. 2.8 on the third one, so that's definitely low. And 8.1 on the third or fourth one. So all 3 of these are low for sure. But I don't quite know if that would cause me to trip a breaker. I would expect that I would blow a fuse. No, those are 30 amp fuses. I mean, we tripped a 150 amp breaker. We're looking for something grander than just a bad run capacitor for a condenser fan motor for sure. We're looking for a big boy problem. Pulled the cover off of the contactors. They certainly don't look great. Definitely kind of caked in there. Let's move on down the line. Yeah, those look horrible. I've seen worse, but oh yeah, those things are toast. Now that would definitely cause us to run high amps. I still don't know about tripping a 150 amp breaker, but maybe, depending on how low it's going, how hot the compressor's getting. Okay, we're gonna keep on going. I'm just going to the common places on these guys and these blower motor wiring. I've seen these rub out before. No, nothing. So there's definitely been rubbing on the bottom of the unit right there, but I don't see, it's not messed with the jacket at all. So the jackets don't look messed up. Huh. Well, I've done about everything I can to make sure there's no direct shorts, and I'm not seeing any. So at this point, you know, one last thing, I need to check those fuses right there. But at this point, I'm ready to turn this on, so I'm gonna check those fuses real quick. Okay, fuses are good. Let's fire this guy up. Hope nothing blows up. Sometimes you just gotta do everything you can to try to isolate and find things. Can't find it, flip it on and see what happens. This guy should fire up into full cooling here. Test current draw, see where it's running at. Indoor blower just kicked on. It's taking too long. I'm gonna put it into test mode. Do it real quick. We're waiting for the stupid thermostat. Interesting. We're running 1.3 amps of current from just the board alone and the transformers. Alright, so we're gonna go C11. That's gonna give us a heavy start because that's gonna kick everything at once. I'm gonna step back when this pops on. Here we go. All four are running. 76 amps, 78 amps. It's cranking. 80. Compressor's running really hard. All but one condenser fan motor running. Is that? Oh, that's this. I was like, why is it vibrating? It's a stupid thing. So condenser fan motor, definitely not working. 78 amps. And this is a heavy, heavy call. This thing's running. We're gonna do some voltage drops across the contactors. See what those are looking like. So the FLA on the blower is 15.7. We're running, actually I think it was higher than that. What was it? Let's go over here. Verify. Evaporator motor 16.7, and then the compressors are all 14.7. So 16.7 on the blower, which we were fine. Right at 15. Let's test the compressors. 11, so that's cool. So with the 10.7, 11, 12, 13, that's kind of high. That might be the one where the condenser fan motor, ooh, 14.3. Okay, so we need to get those condenser fan motors up and running. Oh, the other one started finally, but we're running high current on the compressor. But it's running backwards actually. So we're gonna change those capacitors and see if we drop that current down and see if those compressors calm down when we do that too. I just cleaned this condenser, so it's not a dirty condenser. So these two are amping on the high end, but they might be part of those condenser fan motors that aren't working right. So we're gonna go see if I got 3 caps in the van. Okay, caps are changed out. Let's fire this guy back up again. So we're gonna go to C11. Full unit test. Wait till the decimal appears and back away. All running. 76 amps, and I was incorrect. It's a 100 amp main breaker. All condenser fan motors should be running right now. This one's running now too. We're gonna test them, test current on them, find out. I think it's 2.4 is what they can run. So these are my motors right here. The relays don't look good either. The little ice cube relays, and I can see that some of them are burned. So we're allowed to run 2.4. So 2.1, 1.66, 1.7, 1.8. So that one that's running 2.1. Oh yeah, 2.22. That says condenser fan motor number 3. That's the one that had a bad cap. And it's running really, it almost seems like it's running slow. So we're gonna change that condenser fan motor. My goodness gracious, the heat coming out of that condenser right now is insane. And I'm about to get a rain cloud right now. You look over here, we got thunderstorms coming. As I was coming out here, it was raining on me. So that's my temp in the shade, 107. Let's see what it is out in the sun. So it's about 114 in the sun. It's like about 133 discharge air temp. It's hot, man. But this thing's moving air. Like I said, I recently cleaned it. I took the side panels off and stuff, so but it's moving air. But you know what, man? Listen, can you guys hear that? It sounds like a dry bearing. I'm getting like a dry bearing sound from this guy. There it is. There it is. I think that's the indoor motor. I think that's the indoor blower motor failing. There it is. But it's so hard to tell if it's the motor or that back bearing. It's definitely the motor. Okay, makes me feel a lot more comfortable. You can hear it in there without the bell. I was trying to figure out because the sound was resonating in the back, but definitely the motor. This is what I'm talking about when I say you got to use your senses. Ditch the headphones when you're on the roof, okay? Headphones have no place on a roof unless you're in like a mechanical room where you have to use them for hearing protection. But up on the roof, I'm just working on this unit and I'm listening and I can hear this weird sound, you know? And I didn't hear it when I started it up, but I'm starting to hear it just a little bit at a time, and it's this, you know? Now, this belt is too tight for my comfort as it is. Pulley's interestingly worn. This one's really sharp on the edges too. It's kind of weird. I don't think it's aligned properly. The belt's kind of worn right here and it's really sharp. But yeah, that guy's a little bit too tight. So we're gonna loosen this up too, just to get us a little more life out of this. Yeah, motor's really hot. So we've got a dry bearing in that motor. So I can see, you guys aren't gonna be able to see in here, but I pulled these grease ports off. And there's grease in there, but there's not very much. It's rather dry. I can see the shaft rotating. So we're gonna put a little grease in there. I'm still gonna talk to them about replacing this motor, but we're gonna see if we can help them out a little bit. These things don't have a port for grease. It just has these little fittings right here that were plugging it off. But what I did was I took the Zerk fitting out of the pillow block bearing temporarily, put it on this guy, just greased it till it started coming out the shaft just a little bit. Again, this is just gonna get them by. Probably not using the right grease either. I don't even, people always ask me what grease I use. I just, whatever the supply house has, I really don't pay too close attention to that. So we're gonna grease this one up too. But I wish I could show you guys the inside of that thing, but it's completely dry. You can just see remnants of grease. Since I got the grease gun, I'm gonna go ahead and grease this bearing right here and that bearing right there. This unit has 2 bearings. Also, when you're applying grease to these bearings into the motors, you should be spinning it as you're applying grease, and you don't want to over apply. You don't want to, you know, just jam the thing full of grease. I just basically lightly filled it up, and that's it. Just slightly when it started pumping out the seal right there, not even the seal, but the shaft. Just lightly though. So, and then we're gonna do this one, and I'm gonna loosen this belt up. And don't be that guy. Always clean off the grease when you're done. Make sure you get it all off. That way there's not a massive amount of grease, and then run inside the race of the bearing. Get the old grease out of there. Try to clean up after yourself as best as possible. Okay, this guy's ready to go back in now. It's a little looser than I'm comfortable with, but it's better than it was. Everything's greased up. We're gonna fire this guy up, see if it calms down with that sound it was making. Still making it. Give it a second. I can hear it from the outside of the unit. That's a problem. I've got it in test mode right now. When the unit goes into test mode, it powers down the unit, but the indoor blower contactor is still pulled in. Even when I take it out of test mode, you should usually hear the unit completely stop. There's a number 50 error codes because I messed up the limit switch when I was pulling the blower assembly out. So that should have shut off by now, and it's not. So there's something wrong with the M2. Or M17 board, I should say. I don't know if this unit's going to be worth fixing with this customer. They're probably going to want to replace it, because if they're going to need a board, contactors, condenser fan motor, indoor blower motor, pulleys, I bet you anything these guys will replace it. And the crappy thing is they need to replace this unit, this kitchen, the one that had that compressor issue, before they change that. Huh. Alright, well, we're going to let it run for a bit, see how it does. You know what? I'm wondering if that's something to do with that limit switch. In my head, I'm trying to think if they will, if you have a bad limit switch, if they'll run the indoor blower motor as like a safety precaution. I need to investigate that before I condemn that board. Yep, that's what I thought it was. I just jumped out the limit switch temporarily, and now the blower shuts off. So it's a function, like a safety function, in case the limit switch ever failed in heating. It just automatically runs the blower even if it's in test mode. So what I'm going to do is lock out the heating, because we're not going to use the heating anytime soon, and then we'll order that limit switch when we come back. So the M2 is not a problem, or the M18 board. So all right, I'm about done, man. I'm beat. I've been drinking water like a fish. I'm just dying. It's hot, and it's humid out here for us. It's probably like 30 or 40% humidity. California, that just kills us. We don't know what humidity is here, so I'm wearing a long sleeve and undershirt, sweating like a pig. All right, so that's all I can do for now. I just bypassed the limit switch. I locked out the heating so that way it won't turn on. We're gonna talk to the customer, see what they want to do. So indoor blower motor, pulleys, condenser fan motor, contactors. I should put my gauges on it, but I'm not really in the mood right now. And this storm is about to be here, so I need to get out of here. It's raining already over here. I can see it. So as far as this unit, I don't know what to tell them. They said it was 86 in the kitchen yesterday, 75 in the kitchen when I got here today, and this thing's cranking. No problems at all. No restrictions. I mean, everything's cool with this guy. So I don't know. We'll have to tell him to keep an eye on that. All right, we're back today. We've got a new indoor blower motor, condenser fan motor, blade, pulleys, belt, all that fancy stuff. Let's take a look at this kitchen AC that I was here on, the one that had a plugged up filter dryer. We don't have any active codes, nothing new. The customer hasn't complained, so hopefully all is good at this point. We're gonna go ahead and get started on that dining room AC though. The unit's running full call for cool, and it looks like the motor held up. Didn't trip the breaker anymore. It's been a couple weeks since I was last here, so greasing that thing up temporarily helped to get them through. We're still going to go ahead and replace it though. Pulled it out for easier access, and then I went ahead and put some penetrating oil on everything, all in here, while I start sanding everything up. I also verified that the parts, I have a pulley, and a bushing right there. They're all the correct parts, so we're good on that. So we're just gonna get started on this. I also powered down the unit and made sure we didn't have any power, so we're good to go. Okay, I got some sandpaper here. Start by sanding everything up. Once we get it sanded up, we'll start disassembling, loosening bushings and all that stuff. Work the sandpaper right, you get these real thin strips. You can actually turn the shaft with the sandpaper. I'm cleaning up the inside so I can potentially, if I have to, push the pulley onto it. And in fact, you know what? I don't need to take this one off because I've got a whole new motor. So we're just gonna get this one off. All right, so the bushing right here, I pulled the screw or the bolts that hold it together, that sandwich it together, and put them in the opposite holes. So now we're gonna push it apart, and you're gonna put even pressure on both sides. And then it also looks like we might have a set screw in here that I need to pull out. So we'll check that set screw real quick, and then we'll start separating the pulleys. Yeah, we're gonna apply even pressure. So 1/4 turn, 1/4 turn. Going all the way around. Gotta do it evenly though. It'll pop off. Spun free. Pulled right off. So this motor hasn't been maintained and hasn't been greased for a very long time. And that's mainly why I'm changing it, because the bearings had basically overheated and potentially have damage. Now it's not making the whining noise anymore, but it's been so long since it's been greased that it's just time to replace. Some of these things, this customer's so far out here that it's not worth it for me to try to grease it and come back, and because the callbacks and the amount of labor that I would have to charge them is ridiculous. So we need to set this guy where the other one was set. So we find the old motor, and I'm going to set it based on the old motor settings, which is all the way closed. We're going to start there. So on this one, you got to pull this set screw, then pull that key out, and then you'll be able to adjust it. We're going to tighten it all the way. Okay, now we want to go ahead and put a belt on so we can get a ballpark, and it'll help us to do the alignment. Let's see how tight this is. Okay, that's too tight, so we're going to go ahead and loosen it and then tighten it up. I'm going to use an impact, but it's okay because I got that trigger control. Okay, still loose. Now we can kind of set our depth. Uh-oh. Okay, I'm just using an eyeball to get me in the ballpark. Keeping in mind that when we tighten this taper down, or this bushing, it's going to pull the whole pulley that way. So we want to set our level ever so slightly in, because when we tighten it, it's actually going to pull the pulley onto it. So that's pretty close. Now everything is finger tight when it comes to the set screws and everything. We don't use an impact for any of this because we'll end up breaking everything. Okay, now we're going to tighten evenly. About it. We make sure that we look straight. Looks good. Looks like we can go in just a little bit. That looks dead perfect. I like it a lot. Okay. That guy's already torqued down. And then now we just need to tighten this set screw right here. And there's a key already below it. I can see the key, so we're doing good. This has been cut one too many times. There we go. Okay, so tighten, loosen. Each time it'll go tighter. Looking good. Okay, you want to make sure that this gap stays even when you're tightening it. That will make everything crooked. That one's at 1 3/4. They're about even right now, so we want to make sure we tighten them evenly. Good. Now I don't think that's even anymore. That's right at 2 inches. And that one's at 2 1/8. So we need to loosen this one out. Just a hair. 2 1/16. 2 inches. Actually no, that's 2 and 2. That's even. Make sure we're still tight like we're supposed to be. Looks good. Not over tightened. I have got all the contactors changed out, and of course all the labels flipped back up. Indoor blower motors installed, ready to be started up, wired in, aligned and everything. So we're ready to fire that up and check phase rotation and continue on. Okay, we're gonna fire this. Actually, here's what we're gonna do so I can be careful about it. We're gonna put the unit into test mode. Go shift, unit test. By doing that, it won't run when I power it on. Okay. There we go. And then now we can check rotation. So it looks like we have a call for fan. And it's trying to start, but test mode is locking it out. Okay. So I'm gonna go ahead and take it out of test mode. I'm gonna come on over here. It's going the wrong way. How did that happen? Oh, I know how it happened. Yeah, I'll have to reverse the rotation. I lined it up, line 1, line 2, line 3, but it must not be correct. Let's try this again. See if we're going in the right direction. Okay, we're going in the right direction. Now we just got to make sure that we're not overamping, so we're going to get in here and check current draw now. All right, yeah, so with the new motor, we're allowed to pull 13.8 amps. So we need to go ahead and slow that thing down a little bit. We're going to have to power this guy down, open up the pulley. All right, this motor's pulling too much current, meaning that it's running too fast, okay? So what we're going to do is we're going to adjust the motor pulley. So this is where I had it set. Right here was a half turn open. We're going to open it 2 full turns to see if we can get it to drop. So we're going to open the pulley. So that's 1/2. There's 1. There's 2. So we're going to set it right there, and then we're going to see where that gets us. All right, we're going to see where this guy fires up at now. So 13.8 is what we're allowed to run. Much better. I could even probably close it down a little bit, but I'm probably just going to leave it there. So long as the building's air balance isn't jacked up, and I'll check it on my way out. But we're going to leave it where it is. I like to make it easy. I'm generally a lazy person, so take this off so I can access the motor right from the side instead of having to climb on top of the unit. I can do all the work from right here. All right, everything is running much better. I'm a happy camper, and now it's actually moving air. Before it seemed like it was running really slow. Now we're really moving air, so. All right, we're doing good. We're gonna watch this thing operate for a little bit and start cleaning up all of our messes. Man, where do you stop? All of these relays were burnt too. Look at these. when you're out here in the desert and you've got equipment that is just not maintained as good as it should be, you know, I'm reluctant to not change those relays because I don't want to be back. It's frustrating. All right, hopefully that's it on this guy. Check the TD, should be good, but look at these contacts. Nothing here. So they weren't horrendous, but they're definitely starting to burn. And man, I don't know, you guys probably can't see it, but it is so smoky out here. It's like I'm starting to get a stomach ache. I don't know if it's the heat or the smoke. But yeah, every one of these contactors is like this, just all pitted out, beat down. That's what the desert does to you. It's been about 2 weeks since the last footage, and when I finished up the motor install, I had forgotten to bring up a limit switch to replace the limit switch that I had bypassed. Now, mind you, remember, I just got to reiterate this, we don't bypass limit switches, especially on heaters, okay? Gas-fired appliances or anything like that. Anything where there could be a potential safety problems. Never bypass high pressure controls, any of that stuff. Now, when I bypassed this limit switch, I literally did it just to get the unit operational, and I turned off the gas. So that way it could not fire up. I have a new limit switch right here. We're gonna get this guy wired in. I have power turned off and finish this job up. But yeah, no complaints from the customer. The AC's been working fine. Blower's good. So when putting these limit switches in, they do this on purpose. There is a connector that is really tiny compared to the normal size connectors, okay? You gotta make sure you have those. I keep these in my truck for this purpose. It's so that way you hook them up correctly. Another thing too, to clarify, in the beginning of this video, I showed that I thought or I think I showed it at least, when the limit switch broke, all of a sudden, the blower motor started running, and it was weird. Like, you know, something was funky there. And it is a design of the unit. That way, if the limit switch fails, they run the blower motor just to be sure that there's no potential of a fire in the unit. It would be in my imagination. So when I push this guy in, I have it powered right now. See, the blower turned on. So they do that on purpose for safety reasons, I would assume. Okay, I'm not the engineer that designed it, but that makes sense.
In the case of this video, I bypassed a heater limit switch, okay? You don't ever do that when you have an operating heater, okay, or gas-fired appliance. Never bypass a safety switch, all right? In this situation, what I did was when I bypassed that safety, I disengaged, I completely disconnected the heating circuit so it could not potentially come on, okay? Be very, very careful about that stuff. This was one of those things where it was just, you know, one thing after another. And, you know, I'm so adamant about the wearing headphones when you're on the roof. Guys, I would not have heard the bearing going bad. It was an intermittent problem. And I could not figure out why the breaker was tripping. The customer said the customer didn't even know that it was tripped, but I couldn't find a reason. And then I heard that sound, and then it was like, oh, okay. Now, I get a bunch of people asking me, hey, why don't I rebuild or replace the bearings in the motor? It's not economically feasible. Basically, the amount of time it would take in labor would far exceed the price of the motor, so it's just as cheap to slap in a new motor. But anyways, we got the unit operational. The customer's happy. Still never had another problem with that kitchen AC. I don't know what they were talking about that first time. But yeah, all was well. So I really appreciate you guys making it to the end of the video on this one. Do me a favor. Remember, I do live streams Monday evening, 5 p.m. Pacific on YouTube, work permitting. Also go live on the HVAC Overtime channel on Friday evenings with my buddies. We do just kind of a good hangout show. And if you guys are interested in supporting the channel, there's a couple different ways you guys can do so. You certainly don't have to. I'm going to keep making these videos, support or not. But if you choose to do so, you can support me via Patreon. There's links in the show notes of all my videos. Support me via YouTube channel memberships, merch available at hvacrvideos.com. You guys can get shirts and hats. And then TrueTech Tools. Okay, if you guys are considering purchasing any tools, go to truetech.tools.com. Use my offer code BIGPICTURE, one word. And if you guys do know what tools you're looking for, shoot me an email. I'll generate an affiliate link. It helps me out a bit more. Okay, really, really appreciate you guys, and we will catch you on the next one. Okay.